Imagine a live video feed of, like, a highly delicate remote surgery. The picture on the surgeon's monitor is absolutely flawless.
Right.
But between the camera in that operating room and the monitor is literally 1,000 feet of completely invisible infrastructure.
Yeah, which we never think about.
Exactly. So welcome to today's deep dive. We are unpacking a highly technical product catalog page from HDTV Supply for the Avenview FO-HDSDI-L-SET extender.
That is quite the name.
It really is. Our mission here is to strip away all that dense broadcast jargon and look at how pristine, secure video actually travels across massive physical spaces.
Well, it is so easy for you to just take high-definition video for granted. But for those managing the infrastructure, pushing a standard SDI video signal over, hundreds of feet of traditional copper cable is just a known headache.
Because it degrades, right?
Yeah, exactly. The signal stretches, it blurs, and eventually it just kind of drops off a cliff.
Right, because relying on standard copper over a huge distance is basically like shouting a complex message down a really long, echoing canyon.
Oh, that's a good way to put it.
By the time the sound reaches the other end, it is totally distorted and barely recognizable. But looking at the specs for this Avenview extender, it takes that electrical SDI video signal and translates it into pulses of light over a multimode fiber optic cable.
Yes.
So instead of shouting down a canyon, it's like using a highly focused laser pointer to just flash flawless Morse code to the exact destination.
And what's really fascinating here is how the transmitter and receiver actually handle that light.
Yeah.
I mean, we're talking about pushing a signal up to 1,000 feet for standard definition. Wow. Yeah, and 500 feet for high definition. But the device isn't just this passive glass pipe that, hopes the light makes it intact.
I noticed that in the documentation, actually. It says the transmitter and receiver actively equalize and reclock the signal. But wait, if the signal is already traveling as light, why does it need to be actively reconstructed?
Well, even light traveling through fiber can experience slight timing jitters over really long runs, especially with, high bandwidth video data. If you just amplify a jittery signal, you're really just making the mistakes louder.
Ah, that makes sense.
So reclocking uses this internal metronome. It looks at the incoming digital ones and zeros, strips away any of those timing errors, and snaps them perfectly back into the original crisp rhythm.
Before sending them out to the display.
Exactly.
So the monitor at foot 499 isn't getting some boosted version of a tired signal. It is getting a perfectly timed, mathematically identical clone of the signal from foot 1.
It reconstructs the data stream on the fly, and that active reconstruction guarantees absolutely zero degradation in visual quality.
So it guarantees a perfect picture over impressive distances. But standard heavy-duty copper amplifiers and repeaters can push signals too?
Sure they can.
So why pay the $1,499 price tag on this specific Avenview unit to turn that signal into light? Like, what problem is that solving that copper can't?
So if we connect this to the bigger picture, the real value here goes way beyond just distance. I mean, it is about absolute security. Yeah. Whenever you push an electrical current through a traditional copper wire, that wire inherently radiates an electromagnetic field.
Ah, meaning anyone with a sensitive enough sensor nearby could theoretically read that electromagnetic field and steal the data feed.
Yeah.
Without ever physically tapping the wire.
Exactly. But because this Avenview unit transmits via light through fiber optics rather than electricity, there is literally no electromagnetic field radiating outside the cable.
Oh, wow.
It is inherently immune to outside electromagnetic interference, and conversely, it doesn't emit anything that a hacker can just quietly pick up.
That perfectly explains why this unassuming little box, which only weighs like 5.46 ounces, by the way, is so heavily favored in military, government, and medical environments.
Oh, absolutely.
If you are piping classified drone footage or sensitive patient data across a compound, data security is entirely non-negotiable.
It really changes how you view the physical infrastructure hiding behind the walls of secure facilities. This tiny, lightweight device is the invisible backbone making that zero-compromise security possible.
Which brings up a slightly terrifying question to leave you with today.
Let's hear it.
If our most sensitive medical and military visual data relies entirely on pulses of light running through physical fiber optic cables to remain completely unhackable from an electromagnetic standpoint,
Right.
what happens when adversaries shift from trying to hack the software to physically intercepting the light itself?
Now that is a scary thought.
Something to think about the next time you see a perfectly crisp video feed. Thanks for joining us on this deep dive.